Hi everyone and welcome to Elvatech Academy. My name is Serge and today we will talk about two functions in the ProSpector 2 XRF analyzer that make alloy identification much faster and easier. The first one alloy grade and the second one is compared to alloy. So, if you work with metal every day, accepting scrap, sorting stock, checking product quality or doing incoming inspection, you constantly have to answer two questions. What alloy is this and does it actually meet the grade we need? These are exactly the questions that alloy grade and compared to alloy modes are designed to answer. In this video you will learn what the key difference is between these two modes, how they work behind the scenes, what the analyzer exactly does, and when it's better to use each of them to save time and avoid mistakes. So let's get started. Let's start with the alloy grade function. Its main job is to tell you as quickly as possible, this is most likely this type of alloy grade. After the measurement, ProSpector 2 gets the full chemical composition of the alloy, the content of chromium, nickel, molybdenum, manganese and so on, and other elements. Then the analyzer compares these results with the built-in grade library. For every grade in the library, typical ranges and average values for each element are stored. The instrument overlays your result on each grade and calculates how similar your sample is to the standard. In the end, you see on the screen the alloy grade name, for example, 304, and the match percentage, for example, 98%. The closer this value to the 100, the more confident we can say that your sample matches this particular grade. So, what the match percentage really means? The match percentage is not just a nice number, it's an indicator of how reliable the grade selection is. From 95 to 100%, usually a very clear match. For most production and warehouse tasks, this is more than enough. From 85 to 95, the analyzer has also found a close grade, but it's worth paying attention. It may be a sample with impurities, mixed metal, or a surface that is not prepared very well. Below 85%, this is a signal to be careful. You should not rely only on automatic identification. In this case, it is better to look at the numerical values of the elements or switch to compare to alloy mode. And now let's talk about where alloy grade is most useful. Alloy grade is the mode that saves you seconds on each measurement and hours of work in total. Most often it is used in scrap yards when you need to quickly separate stainless steels, alloyed steels and non-ferrous alloys. When sorting metal stock so you don't mix visually similar alloys. In production for quick checks that the marked grade on the tag matches the actual material. For example, you have a batch of unmarked stainless pipes. You place ProSpector 2 on the surface, run a measurement, and in a few seconds you see alloy grade 304 match 97%, for example. And you don't manually analyze the composition and don't search tables, the analyzer has already done this for you. That's why alloy grade is ideal for fast preliminary identification. And now let's talk about compare to alloy mode. If alloy grade answers the question what alloy is this, then compare to alloy mode answers a different one. Does this sample meet the grade we need for all elements and tolerances? In this mode, you first manually select the grade from the library, for example, a specific stainless steel or tool steel. And for this grade, the library already contains minimum and maximum allowed values for each element. That is the full tolerance window. After the measurement, you see three scenes on the screen. In the first column, you see the measured composition as usual in percentage. In the second column, you see the deviation from the target value for this grade. In the third column, you see the allowed range tolerances for each element in the selected grade. So you immediately see not only what's inside, but also whether each element is within specifications. So now let's talk about where compare to alloy is especially important. Compare to alloy is particularly useful for quality control of finished products, when every batch must meet a defined standard, and QC departments where the exact compliance with requirements matters, not just the alloy name. And also material certification, when you have to officially confirm that the chemical composition meets the norms. For example, you manufacture parts from a specific structural steel. The required grade is specified in the drawing and in the technical documentation. You select this grade in the ProSpector 2 and run a measurement, and immediately see whether all elements are within the tolerance window. If at least one key element is below specifications, that's already a reason not to release the part into production. So let's summarize the difference in simple terms. Alloy grade, when you don't yet know what alloy it is. You need a quick answer. This is most likely this grade of alloy, with the match percentage. The analyzer selects the grade automatically. And now compare to alloy. It's when you already know and assume the grade and need to check compliance with the standard for all elements and their tolerances. In practice, these two modes are often used one after another. First, you analyze the sample with the alloy grade to quickly understand what the alloy most likely is. And then you use compare to alloy mode to confirm in detail that the material really meets the required standard. To make both modes work as accurately as possible, there are a few important points that people often forget. First, surface preparation. If the surface is dirty, rust, painted or covered with scale, it can affect the result, especially when you work in compare to alloy and look closely at tolerances. So, remove rust and paint at the measurement point. Use a grinding wheel or file for critical parts. The second, measurement time. For rough sorting, a short measurement time is usually enough. But if you work with critical components or compare with the standard, it's better to give the analyzer a bit more time to collect statistics. This improves accuracy, especially for alloys elements in low concentrations. This improves accuracy, especially for elements in low concentrations. And the third one, if the match percentage is low in alloy grade. If in alloy grade you see a low match percentage, it might be an intermediate or non-standard alloy, or a mixed sample, for example a weld between two different steels, or the surface is simply not prepared well enough. In this case, it's better to first improve surface preparation, the second look at the numerical values of the elements and, if needed, switch to compare to alloy with the grade you expect. And the fourth, make sure you compare with the correct grade in compare to alloy. It's very important to select the correct grade from the library. If you accidentally choose the similar but different grade, the analyzer will honestly show you that something doesn't match. But the problem might be in the wrong reference, not in the material. So always cross-check the expected grade from the documentation and the actual analysis results, and also the tolerances you see on the screen. Now you know how to use alloy grade and compare to alloy in ProSpector 2 on a deeper level. Alloy grade helps you quickly understand what you are dealing with, and compare to alloy mode lets you carefully verify compliance with the standard for every element. Together, these modes saves you time, reduce sorting mistakes, and increase your confidence in the quality of the materials you work with. If you like this video, subscribe to the Elvatech Academy channel, give this video a like and tell us in the comments which ProSpector 2 modes you would like us to cover next. See you in the next videos!